Hello, this is Jennifer Martinez, and in this section we're going to talk about the unit circle and circular functions. If you remember, an angle with its vertex at the center of a circle that intercepts an arc on the circle that is equal to the length of the radius of that circle has measure 1 radian. So a radian in this circle, this is r here, then the radian is right there. That would be 1 radian. We also saw if theta was a central angle of a circle of radius r, and theta intercepts an arc of length s, then the radian measure is theta would be s over r, or we said s is equal to r times theta. So you can see when this distance, this s, here's the s, equals r, you would have your angle to be 1 radian, which is a fine definition. But this measure, theta, is a pure number because both s and r are in the same units. So say you had feet or inches, for instance, or centimeters, then the centimeters would cancel and theta would be a pure number. Which is why we look at the unit circle. The unit circle is when the radius is 1. So we have here the unit circle, x squared plus y squared equals r. So if we let r equal 1, then theta is equal to s. And then s actually is a real number and can have units. So I have an arbitrary point. So let's erase the 1 radian here and look at theta being this point right here. We know that the radius is 1. And sine of theta is now going to be sine of s, since theta equals s. And we know the definition of sine is y over r, but since the r is 1, it is just going to be y, which is where we get this definition right there. Also, cosine, doing the same thing, cosine of s, which is usually x over r, is now just x. So when we pick this arbitrary point here with this angle theta, which is the same thing as the s here, we can say this point now is cosine of s, comma, sine of s. When interpreted this way, these functions, cosine of s and sine of s, are called circular functions, which brings us to our definition below of circular functions. It says the following functions are defined for any real number s. So now s can be any real number, and it can have units, represented by a directed arc on the unit circle. So here is the arc instead of the angle. Remember that s was equal to theta when the r was 1. So sine of s is going to be defined by just y. We saw that. Cosine of s is going to be x. Tangent, since it doesn't have any r in it, it's going to be the same definition as before. Cosecant is 1 over y, since cosecant is 1 over sine. And the same thing with secant. Secant is 1 over cosine, so it's 1 over x. And cotangent is 1 over tangent, so it's x over y. So now we can redefine our circular graph here to be a unit circle. Again, the unit circle is x squared plus y squared equals 1, since r is 1. And we can look at an arbitrary point here. So let's look at 30 degrees. When we looked at the sine of 30 degrees, for instance, and we saw 30 degrees was pi over 6, so I'm just going to write it as pi over 6 in radians, we knew that that was 1/2 because we looked at the triangle definition. Let's look at the triangle definition. We know that this is 30 degrees, or pi over 6. And across from the 30 degrees, the ratio that we looked at was 1/2 half. So it's going to be 1/2, and then this is square root of 3. So what I'm going to do is, now I want a unit circle, so I'm going to divide this hypotenuse, which is, by the way, the radius. I'm going to divide everything by 2. And this is now 1. So this is the same values there. And you can see that this would just be the y. It would fit our definition. And cosine is going to be square root of 3 over 2, which is just our x, which is the same, you can see, as our old definition in blue, the x over the r. Now it's just going to be x because the r is 1. So what we're doing here is we're modifying our trigonometric functions so that the domains, the angles, are now real numbers and can actually have units. And this is going to be very useful, as you're going to see in future sections. So let's look at an example of finding exact circular function values, which, by the way, is going to be the same answers as finding the function value in radians. The only difference is the process, because now we can just not use the r, because the r is always going to be 1. So 3 pi over 2 we know is 270 degrees, and the point on the unit circle that signifies 270 degrees is 0, -1, and we know that the sign is y, and the y value is -1 right there. And cosine is the x value, so cosine is going to be 0. So each point here is going to represent cosine of whatever angle that you have, comma, sine of that angle. In this case, the angle was, or the arc length, I should say, is 3 pi over 2. Tangent, you would have to still use your old definition of y over x. And the y here was a -1 and the x was 0. So it is still, the process is still the same. And of course, the answer will always be the same. So you can see here from this example and from our previous example of sine of pi over 6 and cosine of pi over 6, that the answers to our circular functions are going to be the same as our answers of our trig functions when the angles were measured in radians. Which means you're not going to find much difference in the homework for this section compared to past sections.